Okay, so I did a video the other day all about what fractions are, and now I'm going to look at the next element that we'd often look at with children, and that is equivalent fractions. So very simply, that just means fractions that are equal to one another. And at school, we might have learned something like this. We probably knew quite instinctively that if we double the numbers in a half, it gives us 2/4. So those are equal to one another. 2/4 is equal to 4/8. 4/8 is equal to 8/16, and we can sort of just keep doubling, per se, the fraction like that. And that's how a lot of us would find equivalent fractions, or we work backwards to simplify. You know, we might simplify 8/16 down to 4/8 and 2/4 and 1/2. And that works well, but it doesn't do everything we need it to do. And also it's good to use images. So that's what I'm going to look at now. So in my introductory video to fractions, I talked about how images when we were at school, or when I was at school, were often circles. So we might have something like 1/2 is equal to 2/4. Now sometimes that is quite clear, you know, I can see quite visually that that is the case. But the problem with trying to use circles is that if I try to do something more complicated like fifths, it becomes a little bit tricky. Maybe I'm trying to compare fifths and tenths. You know, it comes quite tricky to draw these accurately and to actually then see whether 2/10 is the same as a fifth. It's not very clear and it's not very accurate. And so we use lots of different things. This is one of the images or models we might use to talk about equivalent fractions. You've probably seen something like this before. It's fairly intuitive. It's a fraction wall. So it starts with one hole at the top, and then it divides down through different unit fractions. That's a fraction with a 1 as the numerator, the top number. Divides down all the way along so that we can see it really visually. So it works like this. If I wanted to see what was equal to 1/2, I could place my ruler along the half line, and I can see that it matches here. So that's 2/4 is the same as 1/2, or 1, 2, 3, 6 is the same as 2/4 and the same as 1/2. 1, 2, 3, 4/8 is the same as 3, 6, 2/4, 1/2, etc. all the way down. And of course you could draw past the 12ths if you wanted to. And then it also allows you to see other things. You know, you could see what's equal to a third, so 2/6 equals 1/3. It's good because you can see other links as well. So for example, I can see links between things like 12ths and thirds, which I wouldn't necessarily get from other types of pictures. So it's a really useful image to use, and children find it quite intuitive. So I usually give the children these one for reference. These are really very easy to find online, so definitely have a look for these. They are really useful. This is another type of image that has become really useful and well used in schools lately. They're called bar models. So again, it's a way of looking at fractions, quite a lot like a fraction wall actually. So if I start with this top example, this green one, if I was trying to look at eighths, I might see what was equivalent to something like 4/8. So these are all eighths. I can colour in 4 of them. We always tell the children not to worry about being neat and tidy. It takes too long. So 4/8 I've coloured in there. Now if I draw a halfway line along that bar, I can see that 1/2 of the bar is the same as 1, 2, 3, 4/8. Or maybe in a different colour, I might choose to draw out my quarters. So I've got 1/4, 2/4, 3/4, and I can see that 1, 2/4 is the same as the 4/8, or the same as 1/2. So now I've discovered that 2/4 is the same as 1/2, and that is also the same as 4/8. So I can do things like that. Or I could do things like with the 12ths, I could do a similar thing. I might like to look at, let's say I colour in 4 of those 12ths. 1, 2, 3, 4, like that. Well, that's a third. So if I split my 12ths into thirds, I can see that 1/3 of that bar is the same as 4 of the little 12th segments. And maybe I could see some other links as well. I could try cutting it into sixths. So 1, 2, 3, 4, 5, 6 segments there. So each of those is a sixth. And so I can see that there are 2 sixths. So 4/12 is the same as 2/6, and 2/6 is the same as 1/3. So I can see lots of different equivalents, and that can be a really helpful way of using bar models. Some children find them really simple, some children find them a bit confusing to work out, so really it just depends on the individual child. Lots of children also like these, which are Cuisenaire rods, and they are rods which you can get lots of different sizes. So I've got a whole tray of them here of different sizes that you can place next to one another to see what's equal. So I have like sort of 1 whole is equal to 2 halves, or 1/2 is equal to 2 of the quarters, or if I put them all together I can see things like this. I could see that there are my sixths because I've got 6 pieces. 3/6 is the same as 2 quarters. Just as an aside, if you're wondering how I'm calculating what each of these is worth, have a look back to my introduction video on how you describe what a fraction is and what a fraction actually means. It will make a bit more sense then. So that's another way that we can use images and practical objects to help children with this. Finally then, just a quick look back at the calculation side. I mentioned earlier how we might have been familiar with things a bit like this in school. These are quite common things for us to do. We might know that if we doubled, per se, each of those fractions, we would get the next one in the sequence and they would all be equivalent. Well, that's fine, but it misses things out. So for example, by doing this, I don't actually notice that 1/2 is also the same as 3/6, and it's also the same as 5/10. So it's fine for children to use their times tables to find equivalent fractions and to simplify fractions down. That's what we would encourage, but we'd also encourage them to do that using the fraction itself. So for example, I know that looking at 1/2, 1 is half of 2. So I must make sure that that's the same all the way through. So the numerator, the top number, will always be half of the denominator in this example. So 3 is half of 6, 5 is half of 10. And that way I can apply it to anything. I could say I know that 750 out of 100 is the same as 1/2. I could do it with absolutely any number. I could say that 241, 482ths, if that's even a thing, I could say that that is the same as a half because I know that that is half of that. And so knowing how the numbers actually relate to each other is an important part. So it's great for children to be using their times tables to work out equivalent fractions, as long as they're really thinking it through and not just doing this, which is sort of randomly following a pattern. Because although that will get you a certain amount of the way, it might make you miss key things that you could find.